All right, welcome back. We are Game 2007. That's social and multiplayer game design in the winter 2026 semester at Georgian. And it's week 2, part 3 of our broadcast and recording together. And the last part, we talked about a little bit about networks and network topology. We talked about packets and packet switching and a bunch of other stuff. And I do want to make a service announcement before we continue, which is the snow has ended in my area. At least it's not coming down as much as it used to. I'm not sure what it's going to be like in Barrie tomorrow, right? I'll be honest. And I think what we need to do, my friends, is we need to play this by ear. I don't know what it's going to be like. The answer is, for me right now, my plan is to be in person tomorrow at 1 p.m. when I see you guys for the other course. But we're going to have to play it by ear. If it's bad, or if it continues to be snow squalls or, blowing snow and all that kind of stuff, we may decide to keep it online until things get cleaned up. We'll see. I'm not saying that that's what I want to do. I'm saying, I don't want to make people unsafe, right? So, Gage says, still pitch white outside for me. Pitch white, I like that. Yeah, I hear you, Damien. Pitch white, that's good. That's a contrast. Let's get into what I want to talk about next, which is a bit of networking issues, and then right into Unreal Engine's multiplayer system. So networking issues, let's talk about that a bit. Jackson says it's fine. So again, a lot of times it happens around the physical medium itself, and so there's some stuff that we can avoid and potential problems that we can fix. So the first problem that we might have is security. And a good example of this is, I know Damon's right, we have more coming today. The first problem with this is when you log into a system. All right, so anyone in the class ever created a login system, a security, an authorization system where you authorize a user and you create a user database? Anybody? If you haven't, it's okay. All right, I have, and I'll tell you that it's quite involved. Think about all the processes in order for you to create. That's good. You use two-factor, but I'm saying, have you created two-factor authentication? Like you have created that system for someone else to log into? That's what I'm talking about. Like creating the system itself. There's a lot involved when you do this, and part of it is the idea of how you're going to store that information. A primitive one. Alex is definitely not. Yeah, that's cool. I like that. OAuth. Yeah, OAuth is interesting. It's a three-way trust. Logan says, haven't even touched that stuff. I assume there'd be a lot of cookie management involved in auths. We try not to use cookies because those are, you can read those. You can look at a browser and see the cookies. So there's different kinds of cookies you can use. A browser type cookie, and there's also a server-side cookie that you can use. But yeah, we use tokens, web tokens, a lot of times to secure things. There's a service called JWT that we use. And the JSON web tokens, what we do is we use those things, and what we do is we send a series of tokens that allows us to authenticate. Authentication is a complex business, and think about all the things you have to do when you log in. You have to be able to have a user name and a password. Sometimes the password is it's very complex. We're also trying to move away from username and password towards things like two-factor authentication and biometrics, moving away from that. For years and years, we've been trying to get away from using the password because passwords, no matter how long they are not secure. And especially with the advent of quantum computing, it's coming, right? Like I said to you guys before in class, it will invalidate passwords completely because quantum computers can use qubits that are both on and off in a transition, and they can really decrypt even 256-bit security very quickly, almost instantly. So 2FA is good. And like you said, if you break your phone or something that bad happens, that's bad. So that can really stymie you. So think about this, like, you know, and by the way, biometric security has been around for a long time. Your fingerprint, your iris, you know, iris scan, all kinds of stuff, voice identification, and a bunch of other stuff they've done over the years. Some people have been thinking about things like, you know, your heartbeat. Everyone has a unique heartbeat, you know, like your sinus rhythm for your breathing, and a bunch of other stuff. They use biometrics, and they can identify who you are. There's also gait identification, like the way you walk. And it's not just about biometrics, but also time of day. So one of the things that we can use for security is, like, I can only log in at 3:05 p.m. on a Monday, you know, as an example, right? Time of day is another factor. That's another factor in the multi-factor step, right? Multi-factor authentication is, there's parts to it, right? What you know, which is inside your brain, who you are, so some kind of biometrics or specific things about you, where you are, when you are, multiple factors about authenticating. And the more challenging you make security, the more difficult it is for it to be defeated, the more difficult and annoying it is for you to use, right? The more annoying it gets is the more secure it is. It's kind of like a balance between the two. So that's security. Packet loss. That can happen when it comes to, you know, I'm sending information from one device to the other. If you're working in a device where there is some kind of physical problem on the network, or you have a conflict because you're in a Wi-Fi network that is, you know, kind of one network is obstructing the other network, you know, as an example, you can have something called packet loss, which means you can have lost and corrupted data, files, all that kind of stuff. That is another option, another problem that happens with networking, especially when you're transmitting a lot of data over the network or broadcasting a lot of stuff over the network all the time. And then latency. Now that's another killer for us, which is the biggest problem. Imagine if you have to wait to see your character move. You know, push your stick, you know, for your gamepad, and you expect it, you know, your character to move instantly. But it doesn't move instantly. It takes, like, you know, half a second of lag. That's a lot. 500 milliseconds. You know, half a second before you actually move. It's terrible. It's not nice, right? And a good example of that is if you try and do things like pilot a drone from very, very far away, or you're trying to change the direction of a remote control boat, you know, in the water, like way far away in someplace that you have to. There's a bit of latency, right? And then, you know, you turn the boat, but it doesn't respond for half a second. Like, it could be a real issue, right? So latency can have a real issue, especially with gaming. Everything from, you know, you see your enemies here, and the next moment they're there, and they jump from there to there because of the latency. That's really bad, right? Yes, lag is the way it is. Latency means how long it takes for something to, once you send your message across the network, how long it takes for you to receive it, process that message, and respond to it. Latency, right? And usually it's lead time, or you can call it lag. I like that too, but that's what it is. Imagine, you know, you have you're playing a first-person shooter, like it says here, and, you know, fast reflexes are essential, but then no matter how fast you are, the game is there's so much lag, like you want to say, or latency in the game, and it could be for a number of reasons. Maybe your hardware's not fast enough, the server's not fast enough, the network's got a lot of collisions on it, or, you know, packet loss, which can happen, right? And it causes this jump where you see, like, you know, you're aiming down, you know, you have a rifle, sniper rifle, and you've got your enemy in your sights, and you know, pull the trigger, you know, on one side, but by the time that you pull the trigger, you know, the enemy jumps from where he was or she was to somewhere else, and you missed. And it's because of latency, not because they move that fast, but because you're too slow. So there are common issues in the network. Let's talk about something more down to earth for us. Let's move away from the down low black box stuff that most of us don't understand and probably never will, into Unreal Engine's multiplayer system, something we can chomp into a little bit for the last part of our day. Okay. So I've got 5.4 here, but it's 5.4 and 5.5 are almost identical. You can actually look at 5.5 here as well in what this is. It talks about in the documentation here about everything about multiplayer in here. There's a lot to understand about how this all works. And there's all kinds of terms that you may have not seen or heard about before. And when a person starts looking at this stuff for the first time, it can be overwhelming. So that's why we're talking about it together. All right, so that's what this all is. It's all the documentation for the basics of doing multiplayer and networking and all that kind of stuff. There's a great summary here about multiplayer. It talks about all the things that we just talked about, like for example, networking architecture. It talks about that to client-server gameplay examples and a bunch of other stuff here. If you actually read this, if you're interested, there's some great documentation here on the Unreal Engine site, and that tells you everything at a very high level. Anyway, okay, so that is that stuff. I want to go into it though, and so there are again 3 networking modes that we need to think about, right? One of them is standalone, and a lot of times we have this mode, and a lot of times we want to play single player games. We use a standalone mode, right? And if I go back, let's go back to Unreal Engine for a second into our little example. And you can see here, standalone mode happens here. So here's our if I want to play the game, I can play the game like this, and that is standalone mode. If you click these 3 little circles, these ellipses here, and if I kind of move my mouse down to the bottom where it says multiplayer options, you can see that there are a number of players you can assign, and then net mode. So right now, by default, only one player is playing, and the net mode is standalone. We've seen some of this before. Now there's 2 other options. Play as a listen server. So the editor will act as both a server and a client, and then play as a client. The editor will act as a client, and a server will be started for you behind the scenes to connect to. Okay, so that's the 3 modes that we have right now. All right, so dedicated server. If I'm going to play a first-person perspective game, most likely I'm going to have a dedicated server that doesn't do any rendering at all. It just manages the network for me. That's dedicated server. And then I might have a bunch of clients, users or players that connect to the dedicated server, and the dedicated server will serve out or communicate with each of the players that are connecting to the network. Okay, so that's kind of how it works. We can also create something called a listen server. And the listen server is what we're going to be doing in this course this semester, right? So the reason why is because they're really easy to set up. So if I have a listen server, that means that my client, my server itself, this computer, can act as both a server and a client. Okay, and we've seen that. For example, if you want to create a game, a Minecraft game, a server at home, you could make a dedicated server if you wanted to, or you could play as a listen server. And they don't cost you anything. No, they don't cost you anything. Listen servers are something that you can create right now, and we're going to do that right now. Okay, so that's what we're going to do. So for now, what I want you guys to do is inside of our little example, I want you to go here and choose play as a listen server. Click that button, or click this little option, right? So that's the first thing. The next thing is let's increase the number of players. So you can have up to 4 players, but let's add 2 players to the listen server. Okay, that's what we want. And just with those 2 options, number of players 2, again, I'm clicking this little ellipses to get here, and net mode is play as a listen server. And if I press play, then what you're going to get is 2 players. You can see here there's a separate little screen here, and this screen can be controlled. If I click into it, I can control the second player, and that's my client, right? And if I Alt tab, I can tab back into this one, and this is my listen server right here. This is my server and my my client in one. Okay, so that's what it is. So 2 players, and they're using their own interfaces. So there's this one player, and there's the other player. Okay, so that's how it works. And that is the basics of how we're going to be doing networking this semester. All right, so positives and negatives about a listen server. Super easy to set up, right? That's the positive about it. I can set up a listen server in 2 seconds, right? Like we just did, right? Especially with Unreal Engine. Unreal Engine is made for networking. It's made for that. It's been made for networking from the very beginning. You know, the Unreal tournament, Unreal itself. I mean, you know, like there was a whole game that was made just for Unreal, right? Like the Unreal game, right? Back in the day. And it was all first-person perspective shooters, like an FPS. That's what it was, right? So out of the box, this is where Unreal Engine is just far superior to Unity because it's so easy to kind of set this up, at least for now, okay? So back to this, right? And that's the first part. So we want to play as this. Now there are some other options. Let's talk about some options that we can set up. So if I click Advanced Settings, right, as an example, it'll take us here into the editor preferences. Okay, so let's do that. So play in editor. Game gets mouse control. Okay, there's options. Use mouse for touch, right? Show mouse control label, and we're just going to keep scrolling down. There's viewport resolution. So game viewport settings. So common resolution 640 by 480. So what this means is this is the resolution that I'm going to be hitting. You can see that there's also different phones I can target and that kind of stuff here for viewport resolutions. You know, play in a new window, play in standalone game, command line options, and a bunch of other stuff. Now, what we really care about is this part here where it says multiplayer options. So here's something, launch separate server. And this is rarely used option that will launch a separate server, possibly hidden in process, depending on the run under one process, even if the net mode does not require a server, such as standalone. Okay? If the net mode requires a server, such as client, a server will be launched for you regardless of the setting, and this allows you to test offline server workflows by connecting open 127.0.0.1. 127.0.0.1 is the IP address of your local host, your machine. That's another way of connecting to your own machine. Okay? And then the server ports. So we have an IP address, and then we have ports, and there's some very common port addresses that we want to talk about. Port 80 is your web port. That's usually where your Chrome browser and other kind of browsers connect to when they're using HTTP protocol to communicate with a website. Port 80. All right. There's other ports that are very important too. Port 443, you know, and which is usually used for email, and other ports, 3309 for databases, and a bunch of other ones that too many to mention. Okay, but you can use your own port. A lot of times, what we do is we create a port. Think about it as a door that's to your IP address that you've opened. You've opened a port or a door. That's where port comes from. The name port means door in Latin, porta, right? Or in Greek too. Portal, think of it that way. That's where port comes from. And that port is a door or a window into your computer, right? When you open a port, you allow access into that port from outside, okay? And that's why you limit the ports that you have open. For a long time, we had things like port sniffers that would be able to sniff all the ports on your network on the particular IP address and find anyone that's open and then intrude from there, right? So be careful about these things. So play net mode. So play as a listen server. That's what we've chosen. That's what we have here. A run under one process. Okay. Now what this does is it is a for performance reasons we use this, and that's why this is checked. Play under one process. If you uncheck this box, then what's going to happen is it will launch another instance of Unreal Engine just for your networking, and it's going to take more resources from your computer. So please leave this checked for now. Okay. However, sometimes you want to uncheck this because especially if you want to figure out which, whether it's a client or the server that's having a problem, you may choose to uncheck this for debugging purposes. Okay. Let's keep going down here. Enable network emulation. You can do this when it comes to debugging, and what that'll do is it'll simulate things like noise on the network, packet errors, and that kind of stuff. And sometimes we want to do this kind of stuff like network traffic, so that we can troubleshoot what it would look like on a busy network. Okay, so that's the kind of stuff that we can do as well. Client, how many clients are there? Primary pi client index, that starts off 0 is your client index. When you're playing inside the editor, that's what it is. And route gamepad to second window. So you can do that. If you click this option, that means, let's just try this, click this option. Let's leave this editor preferences thing open too, so you don't have to go back here. And if I click back to level and if I press play, then what happens is if you have a gamepad, it goes to this part right here, right? So the second window gets a gamepad immediately. That's something that can happen. Back to this. So we can leave this unchecked for now. Okay, create audio device for every player. Definitely want to check this if you want both players to be able to hear audio. So that one we would check this on. Okay, actually, if anything, we like to check both of these on. All right. Client fixed FPS, you can actually do that. You can have an array of fixed, frames per second that you want to give your client. In the server part, if you open this up, here's the server port that's being used, 17777. That's the default server port. You can change this if you want to. You can server map name override. You can change the name of the server if you really want to. You can have other game options for the server. There's some other things you can switch on here from an advanced setting perspective. And so on. Okay, but those two options here are the ones I want you to change. Route gamepad to second window and create audio device for every player. Okay, definitely put those on. All right. So again, a few options to turn on. They're just check marks, really. And if I run this again, again, what you're going to get is audio on this device as well as audio on this device. So again, you see there's two. There's a window here. You can expand this window to make it bigger if you really want to. And you can see that this is net mode client 1. That's what it says here. Okay. It does not identify this one, the big window here in the editor. That is your listen server. This is where your server and client here. Here it's only client in this window here, the one that I'm looking at, this one. This one's only client. This one is client and server, okay, together. All right. Replication. Let's talk about this a bit. One of the things you need to do for your assignment 1 is replicate your variables. All right, we're going to talk about how to do this. So really what it is we want to reproduce game state information between server and client. And that's what replication is. The replication system allows for this, high-level abstraction and low-level customization, like it says here, and it makes it really simple for, to manage different scenarios. So if replication is enabled, then for an actor, all instances of the game running on different machines will be synchronized. Okay, that's important to understand. And on the other hand, if replication is disabled, the actor will only update its functions on the machine where it was spawned. So now what I'm saying, when I say actor, I mean like a box. If I, add a box to the scene, each instance of the game will see that box, that cube, as an example. But if it's not replicated, I might do something on one side and it won't show up on the other side. Replication is a form of communicating over the network where I broadcast my signal that I'm doing something, whatever I'm doing here to this one is happening over here. Replication is what we want to manage on the server. So wherever the server is, whether it's a dedicated server or if I'm using the listen server, the server machine is a single source of truth. That's where we do all the work, right? We broadcast from the server. Okay. So some of the most common elements that we want to replicate during a multiplayer game are creation and destruction. I want to, break a, something or whatever. Movement, very important. Variables, components, all those kind of things we want to replicate. And there are, however, things that we do not want to replicate. For example, particle systems. Do we really care that this fire on my server looks exactly the same as the fire on the client? No. We want to keep some of that randomness. And it's okay if my fire in my torch looks different than your fire on your torch. Who cares, right? And imagine there might be 50,000 particles, in a fire emitter, if it's really cool looking or whatever, right? Do I really want to manage each of those 50,000 particles and synchronize them across the network? That's a lot of broadcasting, right? I'm broadcasting to every client on the network. We're just talking about two players here, client and server right now. But imagine if there's like 100 players. Every player gets the same signals across the entire network. The server broadcasts all that stuff. We definitely don't want to broadcast particle systems. That's local, okay? Other things like skeletal and static meshes, things like ragdolling, all that stuff is local, okay? We don't do any of that stuff on the network. Same thing with sound emitters. So the emitter makes sound, but we might hear slightly different sounds and attenuation depending on the system. We don't care if the sound is perfect, right, or whatever. Okay. Hopefully that makes sense. A network role, and we're going to talk about this in a second. A network role. So there's two types of network roles, right? We have a authoritative role, and usually that is the server. The server has authority, right? And there's also a proxy. So there's two types of proxies, right, that we're going to see. And in order for me to talk about this, I want to actually do it with you. So let's do it together. So back into this. We have this system right now. And right now, all we have is a single player start. Please, that's bad. If you notice when we run this for the first time, what we're going to see is we're going to see these two little players right next to each other. Okay? And by the way, you can see the server is on the left all the time. Right? Let's try this again. If I run it again, the server is on the left because it gets spawned in first, and then the client. A disadvantage of listen server is that the listen server has an advantage over the client because the server and the client for that machine are one. So therefore, there's zero latency, right? So the client on the server, the listen server, has actually an advantage in terms of latency compared to the client that's off the server, right? That client has latency because you're communicating or lag between the server and the client, usually between some kind of physical medium, right? A wire or Wi-Fi, right? So what we want to do here is we want to separate these two player starts. Let's do that. So we can kind of pull this over here on the left. That's player start, the first one, and we can just alt drag to kind of make another one, right? That's another player start. That's player start 2. And if we actually press play, just like we did last week, you're going to see that the second player will start here, all right? And then if you notice, the second player will see the first player from that angle. And I'm just going to kind of rotate around. You can see that movement right now is replicating. So where is this happening? So if I go into blueprints for a second, here under blueprints, and if I go into my character, let's go into my character or our character for a second, and I want to show you where all this stuff is. So this is the character. If I scroll down, right, and this is the entire character itself, you can see there's a lot of stuff in here, physics and a bunch of other stuff. And as I scroll down, you're going to get into this area where you have replication. Okay, there's your replication, right? And notice it says that a couple things have already been checked. One is net load on client. So what this means is that the actor will be loaded on a network during on network clients during map load. So as soon as the map is loaded, this client is loaded on the map. That's what it means. Okay, that's net load on client for the first time. Okay, then replicate movement, which means if I move, the client moves. Like this actor, remember this is an actor. The actor is the superclass of pawn, and pawn is the superclass of character. So if an actor is supposed to move, and you've checked on replicate movement, if the actor moves, as an example, then it will be broadcast from the server to all the clients. So that is replication in a nutshell, right there. So those two things. Replicates itself is another thing. So when I put replicates on, if true, this actor will replicate to remote machines, right? So that's what this does. So you need to have this checked, replicates by itself at the beginning, just this. Replicate movement means you want it to move, and net load on client means it will load when the level loads. So these are different check marks that mean different things. Let's try some stuff. So here's an example of some stuff we can try. Okay, let's just lower down the camera speed a little bit for myself, way down here. Let's suppose I want to put a cube here. So I want to go to my button here, quickly add to the project button. And on the left, you see some shapes. Let's add in a cube shape. There it is. There's my cube. And the cube is an actor. Okay, there it is. And if I was to look at the cube itself, right, and here's the cube actor, and if I scroll down, even a cube actor that we've just put in, if I scroll down enough, you're going to see that it has replication. And in the replication, it says net onload client checkmark, which means if I have it checked, then I'm going to see when the level loads, this actor loads. Let's uncheck it to see what happens. So here it is, but if I press play, now you're going to see that we see the cube. Here it is on the server. You can see the cube, but on the client, it's invisible. And in fact, the client can do some really weird stuff and try and go right through it, and it'll create like a weird effect where on the client, like the client will move in a weird janky way because it can't see, but there's something physically there that it can't interact with. Okay, so you can see that's happening. All right, so yes, here it is in this server, but it doesn't replicate on the clients at all. Okay, so that's something to note. So that's the first thing. So the first thing is if you scroll down here in the cube instance, and if I go down to replicates, right? So you can see that net onload client, it's unchecked. You can't see anything. Okay. Let's check this on. In fact, let's make a little from this cube. You know, what I want to do is I want to make an actor, you know, as an example, as opposed to what I have here, which is just a cube. So I don't want to just have a cube random shape or whatever. I want to have an actor, an actual blueprint that I want to use here as well, right? So so again, if you look at some of this stuff attached to, you know, player start and level and blah, blah, blah. Question for you guys, do you remember, is there a way of converting an actor into a blueprint? How do I do that? Do you guys know how to do that? So I want to make a blueprint out of this actor. How do I do that? So man, remember I can, here's my actor, right, itself, and there's a lot of options here in terms of the way it is. I can merge actor with merge, you know, all this kind of stuff. I can add different events, you know, I can attach to stuff, I can pivot, I can change all this other things here. I can also place an actor, you know, and replace it and blah, blah. But how do I make this actor into a blueprint? Anyone remember how to do that? And if you don't know, we can simply just do this. Let's just get rid of the actor. Let's get rid of the cube. And what I want to do here is let's make a new actor. So I want to make a new blueprint class. Let's try this out like this. And we'll make it of type actor this time. And we'll call it BP_cube. There's my cube actor, right? And inside my cube, I want to add a static mesh. So let's add that in. So static mesh. So here it is. And here's my static mesh. We'll call this the cube mesh. Cube mesh. And then I want to pull in some kind of cube, if there's something like that. And you can see there's a static mesh, which is a cube. Let's add that in, right? There's my static mesh. And if I click away and click back, you can see that the world grid material is the default material. We've talked about materials now. You should know a little bit about that. We can choose other materials here as opposed to the world grid material, right? So there's the widget material X and a bunch of other materials, right, that are here. So lots and lots of different kinds of materials that you can pull in that are part of the project, okay? But for now, let's just use the world grid material. That's fine. That's here. And what I want to do is I want to take this cube mesh and I want to make it the root of the project. That's what I want to do. So compile and save. All right, so that's my cube. And now what I want to do is I want to drag that cube into the game. Here's my cube. Okay. And let's make my camera just a bit faster because I'm gonna go crazy with like 0.1. That's not what I meant to do. Camera speed. So there's my cube, and now if I look at my cube itself, and if I go to you know, kind of all the options, not a lot of options for it, but if I scroll kind of down to the cube mesh itself, right, then we'll have a replicating kind of section where it kind of replicates, and it's all around networking. Okay, so you see sockets and all that kind of stuff, variables and materials. And if we type in replicates, right, then you can see that it says component replicates or replicates to physics. That's what it says here. So that's one thing. So by default, because it's a static mesh, you know, that I'm clicking on, it has some things. This, although it's a cube mesh, this does not represent the entire blueprint. The blueprint is represented by this self, right? So self gives us additional options right down here, everything from world instance to data layers and a bunch of other stuff. Okay, so that's important to know. So there's a replication section. We can sit there. So if I type in replication, the whole replication section is there. If I click on the cube mesh, you can see it's only a limited filter. It only gives me a couple things here because the cube mesh is a component, right? But if I click on self, you can see that I get a bunch more stuff here. So here's net load on client. We've checked this on, but replicates is off. Replicates is off. So if I compile and save, and if I go back to this and if I play, again, you can see that my server can see this thing, right? But my client, okay, my client can also see this thing. There it is. Here's my client can see this thing. But you know, if I want to make this object, you know, kind of modified by physics, let's try this out. So let's go back to the cube, and what I want to try and do is, if I scroll down to the cube mesh itself now, and if I go down to simulate, you know, generate hits event, but I want to simulate physics on this thing, right? Then notice this block all dynamic is the way it works, and it says collision enabled query and physics. I want to kind of simulate physics on this thing, so I want to turn it on so that when I put this in place, I want the physics engine to work, right? So here, physics, where I want to turn this on, simulate physics, right? I don't want to generally talk about mass, but I want to enable gravity on it so it'll fall. All right. So let's try this. Compile and save. And if I press play, you can see now that it fell to the ground. In my, you know, I can move this around here with my my server, right? I can do that. But if I look at the client, you see where it is right here. Here it is, right? If I interact with it, you can see that I'm interacting with the object. There it is. Here it is. I can see that I'm interacting with it. But notice how it's different. Notice how in the server view and the client view, we're out of sync. Take a look. So I want to make this bigger so you can see it. So here. There's the view. Notice that the client is seeing this, right? And notice something else, that the client has, you know, it's actually pushing the box over here, and I'm getting some weird janky effect on the client, but the server's not seeing that. Okay, if I switch back to the server and then I touch this thing and I move it around a little bit and I go back to the client, you can see that the client doesn't see what the server sees. The client sees the box over here. This, my friends, is out of sync, and that's not good. So what we want to do instead is, if I go back to the cube, right, what I want to do is, on this part, I want to go back to the replication, and I can, if I check on replicate movement, now we should see the same thing. I also want to replicate this object itself. So there's complete replication here. If I click these three things, now what happens is if I play for this object, here it is, right? You can see that by the way, notice that the client, the server started in a different position. It's random, right? So if the client pushes the cube now, it looks like exactly the same as what the server sees. There's no difference between the two. They're in synchrony, right? So everything from the way physics responds, the location of the object, the spin, the rotation, everything is completely the same, my friends. And it has to be the same, because if it isn't, there is no randomness to this, because if there is, then what I'm going to see and what you're going to see are two different things. So for example, if I jump on this thing, so if I try and jump on the object, and by the way, my jumping isn't very possible here, but let's make it possible. So I'm going to go back to the character, And if I go to the character movement component, by the way, let's go back to that character movement. And here is the jump velocity, which is 420 centimeters per second. And let's increase that to something a little bit more dramatic. Let's make it 600, okay, for the character. Compile and save. And if I press play now, then my character might be able to jump on top of the cube. Let's see if I can do that. There we go, jump on top of the cube. All right, and if I go back to my client, you can see that the client also sees the same thing that the server sees, right? This is the important part about it. But once I take away the replication, then what the two things see might be completely different. And that's where we get into some really weird jankiness happening, where one thing isn't really in sync with the other thing, okay? So that's what replication means. Let's talk about network role. And I'm gonna just get rid of the cube from the scene for now. We'll keep the cube, we might use it another time. But I want to go into this, and inside of the event begin play, or just beyond the event begin play, what I want to do is a couple things. I want to output the network role. So if I type in network role, if I just type this out, right, you can see that there are two types of roles, the local role and the remote role. Okay, so this is how you see yourself, and this is how others see you. Okay. So if I click on the local role, get local role, it's the target is self, that means this thing. And then you have this enum that comes out, that's outbound from this thing. I want to print this out. So I want to use a print node. Here it is. And what I want to do is let's increase this to about 30 seconds so we can see it a little longer. I want to use an append node. Let's go back down and use the string append down here. Here's the string append node. And I want to say something like role, that's your role. And I want to take this output, it's going to convert it from an enum into a text object. Okay, so I'm going to do here, I'm just going to put them all in order. And then what I want to do is I want to output this text object to here. Let's make sure there's a space, so it's role space, right? And I want to connect these two things together. That's what I want to do here. And so then, if I press play, right? If I press play, you're going to see a couple things. One, okay, what you're going to see is the client one role is autonomous proxy, right? And the server role is authority, okay? Autonomous proxy and authority. That's what you're seeing here. That's client one, okay? All right, so now let's go back, and there's some things that you can check as well in here. We don't want to print this out, we just want to print it out as if it's the server. So if the server always has authority, remember? So I can check to see if it has authority. So I can type in has authority, all right? Here's has authority. And if that's true, let's do a branch. So we're saying if I'm the server, that's what I'm saying here right now when I say has authority, I'm the server. If I have the server, and only when I have the server, I want to print out my role. If I'm not the server, I don't want to print out my role. Let's try this out. Compile and save. So if I press play, now let's see what I see. It says server authority. That's my role. And notice it says server authority here. Why? Because we're using that process that I talked about before, which is a shared process in the editor, right? So if I go to the editor and again, and if I type in the word process, type in process, please, in the editor. So this is in the thing here. Notice down here it says run under one process for multiplayer options. Let's uncheck this for a second. Uncheck run under one process, just for a second. And if you're to do that, and it's going to be a little bit longer, but if I press play now, it's going to make a new instance of my of my game. Okay, so in a different window. Let's try this out. Ready? Press play. Notice it says save your level. Okay, save my level. Here it is. So once I've done that, so there's server authority, but then it runs Unreal Engine, another instance of Unreal Engine that's running, and in a whole other window over here. Okay, I can't even click into it right now, right? And what you're going to see is server has authority here, right? But on this one, it has nothing. Take a look. I don't have anything. right? And look how janky the movement is. Woohoo, right? La 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 la. The reason why it's so bad and it's jumpy like this is because performance is low when this kind of thing, when you're kind of running two processes, like I'm running two instances of Unreal Engine at the same time, it's bad. Now there's ways of making this better, right? If you want better performance with this kind of system. By the way, I can't even quit. I can't press escape because escape doesn't exist. This is actually an instance of a game that I've made, and there is no easy way of quitting. We need to have that, right? So so what I can do here is I can go here and press stop, and that'll stop everything. But otherwise, if I don't do that, that process will continue to run. You can't press escape. Escape's not the thing to do it. If you want to press escape to quit, let's make a quit option. So if I go back to my input here, let's make another input action. Okay, let's do that. We've done this before. So input action. Let's call this IA quit. Let's leave it by default what it is, just a Boolean, right? And then inside of my input mapping context here, let's add in a new mapping, right, for the quit action. Here's quit. And we're going to choose escape, the escape key for quitting. So save, right? So that is what we've done. You should know how to do this now. We've done it forever and ever. Let's close this off. And let's go back to my character and let's map in IA quit like we've done before. So we're going to say IA quit. Here it is. And what I want is when the action is started, I want to quit game. All right? And I don't care about just quitting the game. I also want to ignore platform restrictions, so I'll completely quit. That's what this thing does. Compile and save, and this is me quitting the game. So I'm going to say this is a quit the game. All right? And we'll choose a black color for this. There we go. And press OK. So that's quit the game. Okay, compile and save. And now in our player, we can quit the game. I'm going to say save selected, and now it's going to run. And when I do, notice I spawned on the right side this time, and now it's going to generate my other one. Here's my other one. It's coming. It's coming. This is the process. And then, here it is. If I press escape now, it'll quit the game, like it would if we were building for the first time, because it's kind of doing a little build for us. And notice that this one is not quit. All right? If I press escape here, it will quit, but it only quits the window that I have focus on. Okay? So positive and negative about using this like run under one process and unchecking it, it's great to do troubleshooting, because before I was getting print statements on both. The reason why is because it's broadcasting. It's running one process, so it's looking like it's client server, but it's really not. Okay? That's number one. The other thing you can do is what I want to do is if I want to change my frame rate. So one thing that's happening here is if I type in background, right, there's another option which is use less CPU when in background. Okay, let's uncheck that. Okay, so this is another thing we can do to when the process is in the background. So that means that other window, it uses less CPU. So why is this? That's why we have janky movement, between the two. So if I want to use this other way of doing things, if I press play now we're not going to use less CPU when it's a background process. We're going to use all of the CPU, right? So, and where this is great is if I go back to this window, which is launching in a second. Here we go. And now you're going to see that the movement is better. It's not as janky as it was before. Still quite janky, right? Still weird, but you can see that it moves fairly good. And you can see that there's one window that says server authority and the other window that says something else. Okay, let's separate that window, and let's do that in the code before we run out of time. And that's going to be done way up here. So we have two options, right? I want to separate this out, and that's showing you how authority works. If I have authority, then print it out. Let's take this check away. Okay, but now we have a separate process, so we can see the difference between the two. Right? So this is where I'm outputting my role. And notice it says autonomous proxy is what I want to see. Compile and save. So I press play now, and now you're going to see that the role is authority, right? So that's my server role. And this one should say something different. Okay? This one says autonomous proxy. When you see autonomous proxy, right, on a screen, what this means is that this is the client machine. Okay, autonomous proxy or remote proxy, those are the two options. That's what you're going to see when it comes to the other screen itself. That's the remote. Okay, so that's a way of troubleshooting messages. Messages pop up on both screens if you don't do this, right? So again, what I want to show you is you can turn some of this stuff off again. If I go back and go to process again, and if I turn back run under one process, just to know that that is the case, that is the way. You can leave the limit CPU thing on. It doesn't matter, right? It's going to give you more performance. Notice now it's instant. It comes on instantly, but it shows both things. The client one shows role autonomous proxy. The server shows role authority. The server is the left, the big screen. The client is on the right, small screen. Keep that in mind. Don't get confused, okay? Because it can be confusing. Are you with me? All right, next. So now that we've talked network role, that's the thing. The authority is on the server, and then we can have either there's different kinds of proxies. One of them is autonomous proxy, and the other one is remote proxy if we look at the remote role. Pawns and players control. So one thing that we can also notice is that every pawn has their own player controller, just like we saw last week with split screen. Okay, so there's a player controller for each pawn. It gets generated right away. Again, one thing to note is if I press play, take a look what's going on over here inside of your hierarchy in your outliner. Okay, so you can go here and you can see that there's two players, BP_MP character 0 and BP_MP character 1, and then you can see that there is one player controller right here, player controller 1, but you have player state 0 and player state 1, right? That's one thing you see. Notice that there isn't a second controller. There's no like player controller 2 or player controller 0. Where is that, right? Well, one thing we can't see is what this is, what's going on here, right? And the question for you is, right, notice that this guy spawned on the left side this time, okay? Next time what we're going to try and do is make it so that they always spawn in one place. We know that right now it's random. Sometimes they spawn on the left and sometimes they spawn on the right, okay? But we don't know which player is which, as an example. That's important. We can make another little printout. Okay, so here's another thing we can do. We've printed this out. Let's do something more. We can say get player controller. Here's my player controller. And my player controller has 0, right? And for this player controller 0, let's print it out, again, just like we did before. I want to print out my controller. Now remember, there's different things we can do, for printing out the controller. We did this last time, but let's use this print string here. Here we are. And I want to connect these two up together. And I want to print out this player controller, now this is player index, the player index stuff. I want to get the player index, from the player itself, right? So notice that this is, this thing. But if I go type player here, here's a few things to note. So there's player controller and there's also get controller. If I just type get controller, here's controller, right? So this is the pawns controller, right? That's what this is, okay? And if I want to take this player controller and I want to get player ID, right? That's what I want to do. So get ID. Or I want to, so this is primary asset ID. You can see that that's what that is, primary asset ID. If I get player state from my player controller, right? And from there, and if I say something like, then here's player name, and I can also do a unique net ID, right? It can give you different information here, about the player. Here's the get player ID itself. So there's get player ID, okay? So there's my get controller. I'm going to get the player state from the controller, and then from there I'm going to get the player ID. And I want to use an append node. So here's an append node, and I'll say ID, and then I'm going to take this player ID and convert it into a string. Let's move these a little bit away so you can see these things. By the way, these things are going to be your friends in the future when we do all this networking stuff, right? And what I want to do here is I want to output the player ID as well. Let's do it for 30 seconds, and let's compile and save and see what happens when I press play. So here's client 1 is ID 0, server is ID 298. Okay, so that's interesting. So the server's got its own ID, the server's got an authority, and then the player ID is 0. Okay, keep that in mind. So then, which one am I seeing here, right? Who is player 0 and who is player 1? You know, as an example, here's a couple players, an MP0 and MP character 1. Which one is which is the question, okay? And that's something that also we're going to figure out. One thing also is, notice that we say here, server logged in, play and editor. Sometimes you get these weird errors here that says something like, you don't have enough server credentials. Do anyone get that error when you stop playing? I don't have enough server credentials. You have to add login credentials. Anyone get that weird error? If you do, right, if you get these weird errors that pop up, not this one. This one is like saying, hey, you're trying to access something that doesn't exist. Player state doesn't exist yet, right? Because I'm trying to access both players' player state when it doesn't exist. So what you can actually do is you can do a validated get. So back to this, what you can do here when you're getting player state may not exist. So what you can do is, before we get the player ID, we can say that if is valid, right? If is valid, then we'll branch, right? And if it's only if it's valid, right? Then and only then do we want to get the player ID and print this out. So we can do a bit of a check, a null check. That's what this is. So compile and save and play, and you can see that if I stop the game, we shouldn't get that error anymore. But if you get that weird error that says you don't have enough credentials, you know, something like that, the way to fix that is go back to your Epic launcher, right? And don't do this now because it takes some time. But in the Epic launcher itself, right? And if I've got 5.54 as my main version, you can click verify. And what verify will do is it'll add all the credentials for you that you need when it comes to multiplayer. And it'll remove that error. It won't ask you those questions anymore if you verify. But you need to, it actually takes an installation step. So please only do this when we're not together. All right, like do this on your own. It's going to take time for you to verify. And then you won't have that weird, your session doesn't have enough login credentials or whatever. Okay. Okay. So that's that. So yeah, so there's a couple things we can get IDs. That's something that we can also get, you know, from the player. And there's many other things that we can get as well. So pawns and playing control, we can say that the player controller is created for each connected player. That's the player controller itself. And that means, remember last week what we did, we had a separate player controller for what we did, as opposed to having all the controls that we had inside of the character. We had all those controls inside the player controller. The player controller is a good place to have all those controls because it's shared between both client and server. Okay, so later we may refactor our project so that we do that. So the owning client, we've talked about this. Who owns this thing? The pawn that owns the client, right? We can say that an item will be owned by the same connection that owns the pawn. All right, that's important. Relevance and priority. So there's two other things we have to think about. We're going to learn all about this, by the guys. We're just scratching the surface today. Relevance is something that we want to think about as well. And when we say something is relevant, it's something that I want to communicate across the network. A good example of that is user interface. There might be a user interface that is only relevant to the client, but not to the server. And a good example of that is things like an inventory, or something that the client only cares about, but the server doesn't really care to replicate across the entire network. Okay, you can turn relevancy on and off so that it can save performance from a server perspective. So you can deem actors not relevant as an example, and then they won't be replicated across the network. Remote procedure calls. We're going to use remote procedure calls, or RPCs, when it comes to using functions, right? And we're going to do a lot of, there's three kinds of RPCs. an RPC can be sent from the server. We want to do more of those, right? An RPC can be sent from the client, right? And the RPC is, I want to do a multicast. I want a client and server, all right? Those are the kinds of remote procedure calls that I want to do. Remote procedure calls, what it does is it activates that function, right? And it comes from the server. The server says, activate yourself. That's what a remote procedure call is for the most part. A good example for a remote procedure call is when I want to do things like show the animation. Remote procedure call, show that animation. And I do that from the server. Okay, the server is your single source of truth. Like I said, it's going to get you out of a lot of trouble. We already did the project setup. We did all this kind of stuff already. We did all this. We did that way ahead of time. So we did all these things before. We added a player start. One thing to note is that we have a lot of janky movement right now in our project. So if you actually run the project really quickly, you're going to see that I can move right pretty quickly as a server. But as the client, if I go to the client here for a second, and if I run, notice that I can't run. Even if I press the shift key, I can't go as fast as I would if I was the server. I can't do that, right? And even jumping is limited and stuff like that as well. And the reason for this is because the server stops you from running, okay? And it stops you from running because you could cheat. So there's ways of making it so that the client could cheat and appear in different places, or have different things happen all the time, and that's what contributes to this janky movement. The sprint action itself, right, needs to be initiated by the server. So this next week when we get together, we're going to talk about remote procedure calls, and we're going to fix this janky movement problem, because what's happening is, the server has to tell you that it's okay for you to sprint, right? Otherwise, it's not okay. If we left it up to the client can be hacked. I can cheat with the client and make it, give myself unlimited speed or unlimited health or unlimited anything I want. But the client is not the single source of truth. It's the server. And that's going to prevent cheating from happening across the network. And because of that, we have this weird janky movement right now because the client can't run. It can't. It won't allow it to go fast because the server has to tell it that it's okay to run. Okay, so we're going to fix that problem. We already did this part. So let's go back to that and let's take a look and think about how I would fix that problem. All right. So again, if you think about the sprinting, this part right here, right? I really only want to do the sprinting if I'm the server. That's the only time I want to make this happen. If I've got server authority, then I want to be able to do the sprinting. So I mean, you might be thinking about something like this. Well, if I has authority, right? If has authority is true, I'm just going to put that in there, right? Then let's sprint, right? If I have authority, then I can sprint. That's what this means. Well, let's see what that does if I try that. Is that enough is the question. So if I run this thing and, that means the server can sprint, right? So here's the client, and now the client still can't sprint. Even though I put that in there, the client can't sprint. That's not the solution. So, going back to this, it's not enough for me to do a case like this. It means only the server is going to be able to do this, not the client. That's what this means, okay? What I need to do instead is, I can't do that here. I can't do that here. I have to do a remote procedure call that we're going to do next week in order for us to do that, all right? So I'm going to kind of remove this. And what I could do is I can make a custom event, right? Here's a custom event. And let's call this custom event sprint, okay? And we'll say sprint server, okay? Sprint server. And what I want to do is if I click the custom event, notice on the right-hand side here, it has some options. And one of them is not replicated, okay? I can choose, instead of not replicated, I can choose run on server, right? So there's run on server. So now, sprint server, that's why it's called sprint server, I can take this stuff here, this stuff, and I can get the character movement component. Again, let's get a copy of the character movement component. Let's put it over here, right? And what I want to do is I want to disconnect this part and just move this to here, right? So there's a middleman, if you will. So this is a little anonymous, a custom function that I'm going to use to make it move faster. And then in here on the triggered, right, for the, well, actually it should be the started, I want to call sprint server, this one. Okay, so what this does is it basically says, look, I'm not going to just sprint. I'm going to use the server to make me sprint. I'm going to go through the server to communicate when it's okay to sprint. And that's what this does. Okay, let's see if this is enough. So compile and save. And if I press play, and if I look at the, I only care about the client, this one here, right? Can I sprint? And you can see now that indeed I can sprint now. But still, some things are funky. Look at that, like weird jittery stuff that's going on. Yes, I can sprint, but it's like I'm finicky. It's a weird kind of like jittery stuff that happens, right? It's still trying to slow me down, right? And it's trying to slow me down because of this problem that I have. But I can actually sprint now because the server's telling us it's okay to sprint. Okay, so that's something that we're going to fix. You can see how difficult this is. The other thing to do is try this out. So instead of just making it sprint, we can also make it something called reliable. So when we click on reliable, it adds network traffic to the call. Okay, so not only am I saying it's from the server, but it's reliable, which means it's for sure going to work no matter what. It's almost like I'm adding additional traffic or overhead to make sure that this call is functional. So again, going back to this, if I press play, let's see if that makes any difference. Okay, so again, I'm sprinting. You can see I'm sprinting with the client. I can sprint now, but even though I'm reliable, I'm still got some jankiness to me. The other way to do it is instead of using the server, run on server, I can use something called multicast. Here's multicast. Multicast means it'll run on server and the client, not just on the server. Let's try this out. Compile and save, right? So now we should rename this thing. Instead of it being called Sprint Server, we should call this Sprint Multicast. And we'll talk about all these things in a bit. And if I compile and save here, and if I press play, and then let's see what happens now. Is it any better than what I had before? And now you see that I can't sprint anymore. Right? Notice? No matter how hard I try, I can't sprint. But I've lost that janky feeling. I'm not, bouncing around like I did before. Okay, so that's another one. And one more time. By the way, there's combinations of these things we can use as well. We'll talk about that next week. If I run on owning client, that's another option. So if I do this sprint, let's call this sprint client. Okay, these are all different options here. I can leave the reliable on, right? And if I press compile and save, and then press play, will this allow me to sprint? And you're going to see that it does not. Okay, there you go. So the only thing that seems to work, like I said to you before, right now, with the knowledge we have about this remote procedure call, which is what we're doing, right, is we want to run this on the server. Like I said, the server will save you 9 times out of 10. Right? I'm just renaming it so we know what this is. Okay? But still, we have an issue. And we're going to fix this issue, like I said, next week. Even though we can run now, it's still slowing us down. And can anyone, challenge for you guys, can anyone know why it's slowing us down as opposed to always making us sprint? Anybody? There's a bunch of reasons, but one reason we want to think about is, what about this side? What's going on there when we let go of it? There's one instance of the server that is walking, right? And the other one that's running, right? So we might want to try and do this over on the server as well, right? Where we say, well, if it's completed, then stop moving, right? Kind of thing. So we can try that. We can say, stop sprinting. So we can add a custom event. So again, that's how we do it. Add custom event. And sorry guys, I'm almost finished. And we'll say stop sprinting. Stop sprinting. Server. There it is. We can make it so that it's on the server. It's also reliable because they're moving, right? And I want to grab this thing, copy, paste. So I want to get a reference to the character movement. And then I want to grab this and then just connect it here. Right, there we go. And then what I want to do is get rid of this altogether, okay, and call stop sprinting on the server, where I want to connect this to this. Here we go. Actually, we just don't need this reroute node at all. We can just get rid of that and just connect it. There we go. And if we do this, now both things, starting and stopping, are happening on the server. And again, the question is this enough? And these are the questions we're going to answer all semester long. As you can see, it's good to start, but still got that rocky issue. And there's one thing that I can tell you that's causing this problem, and it's because we need both a cast that we're going to have, which is basically a multicast, and the server RPC at the same time. And that's the answer. Okay, so that is a little bit of an intro into Unreal Engine's networking. We're going to do more of this next week. Please stay tuned. There's a lot to this, a lot more details than you might think, and we're going to get to it one piece at a time. Questions around this. I'm going to put this up on DevOps so you have access to it, so you can see it, and you can try it out if something goes wrong. The only thing that won't go up on DevOps is this, this stuff here. So anything in the editor preferences, some of this will not go up on DevOps. You need to kind of add in 2 players, and you have to change the net mode to listen server. If you don't do that, then it won't go up on DevOps. The other thing we haven't done, which we could do, is something called skinning. We haven't done that either. For example, both of these players, player 1 and player 2, or player 0 and player 1, have the same materials, right? So here we are, we can see the same materials. And we've done this last time with our split screen, but we can do skinning, that's what it's called, to change what each player sees. For example, player 1 or player 0 will have a green uniform, and the other player might have a red uniform with respect to player 0. But with player 1, they'll have the green uniform, and the other player will have the red uniform. In other words, each player will be the enemy in their own, kind of thing to the other player. To themselves, they'll be the good person, the good guy. Actually, that's how it is in the best stories out there. The enemy always thinks, the bad guy always thinks he's the good guy, right? Or he's the main character of the story, right? So we can do that with skinning. We can change the way things work with skinning. Okay, my friends, thank you so much. Hopefully the weather is better tomorrow. If it's not, I will send a broadcast saying we're gonna stay online. If it is, the plan is to meet in person. Okay, guys, thank you so much, and we'll talk again tomorrow. Thank you so much. See you. I'll stop recording now.